Hi everybody, this is Dr. Verol, and in this lecture we'll still keep talking about the confidence intervals. So today's lecture is going to be on confidence interval for mean when the population standard deviation is not given. Okay, so in the previous lecture we covered the confidence interval for mean when the population standard deviation was given. So that was a different case. We used the z-table to determine the confidence interval for mean, right? But in this part of the lecture, we're dealing with confidence intervals when the population standard deviation is not given. Again, don't get yourself confused. I'm saying the population standard deviation is not given. So the sample standard deviation may be given in the question, or you may need to calculate it, but we don't know what the population standard deviation is. So if this is the case, if you don't know what the population standard deviation is, in other words, if you don't know what sigma is, we cannot use the z-score, right? We cannot use the z-table, so we have to use something else. So instead, we will use the t-score, or sometimes this is named as student t-test. And there are certain requirements for the t-test. First of all, the sample size needs to be smaller than 30, and population must be normally distributed. Again, the sample size needs to be less than 30, and the population must be normally distributed. So this reminds me something. So that means if the population needs to be normally distributed, that means there is a similarity between t-test and the z-test. In fact, t-test is very similar to the z-test. It just handles the small sample size. Just a recap from one of the previous lectures. As you remember, standard deviation calculates the difference between a data point and the mean, right? And if data points are available for calculation, it's much more likely that they will be in the center of the distribution rather than the tails. So the t-distribution here, or the t-test, accounts for the small number of data points to adjust multiplier accordingly. So t-test is responsible for adjusting the multiplier when the sample size is less than 30. Okay, and the formula for the t-test is t is equal to x minus mu divided by s. Again, s is the sample standard deviation. Okay, and critical values are calculated by T alpha over 2, or it's given by T alpha over 2. So the overall purpose of t-test, if you Google, what is the purpose of t-test? T-test is usually used when you want to compare the two parameters of two distinct groups. Let's say that we want to compare the means of two different groups. So t-test is an appropriate test to take. But again, I want to mention that the sample size needs to be less than 30. Okay, so you have to consider that condition. The sample size needs to be less than 30, and the population must be normally distributed so that you can compare the means of two different groups. T-test is also used in confidence interval for mean when the population standard deviation is not given. So making the long story short, t-test has different purposes, and this lecture is designed to cover the fundamentals of t-test and how t-test is applied in confidence interval for mean related problems. Okay? All right. The t-distribution has a parameter called degrees of freedom. Degrees of, just rewrite this, degrees of freedom. Okay, and degrees of freedom is represented by d dot f. Okay, and d dot f, which is the degrees of freedom, is calculated as the sample size, so n minus 1. Remember, n was the sample size. Okay. Well, you do not have to know how degrees of freedom is created to perform a statistical analysis. So you don't have to know the logistic behind the degrees of freedom, but let's just briefly talk about it. Let's just introduce what degrees of freedom is. Okay, let's give an example. Let's assume that you're packing for a vacation and you put 7 t-shirts in your luggage, and you want to wear a different t-shirt every day of the week. Okay, on the first day you can wear any of those 7 t-shirts. The second day you can choose from the remaining 6. On the next day, which is day 3, your choices are down to 5, and on day 6, you still have 2 choices left, right? So if you keep going, after you choose your t-shirt for day 6, you have no choice left that you wear on day 7, right? So you must wear the one remaining t-shirt in your luggage. So 7 minus 1, 6 days of t-shirt freedom. So for the first 6 days, you had available options to choose from. But on the last day, you're obligated to wear the remaining t-shirt in your luggage. So which means the last t-shirt is set in stone. That means that's the only t-shirt, that's the only piece that you can wear. This is why they say it's set in stone. Okay? So let's go over an example. Let me open a different page. Okay. Let's say that we have a sample of 23 from a normally distributed population, and we want to find the critical value. Find the critical value T alpha over 2 T alpha over 2 for a confidence level of 95%. All right, so we just mentioned that t-test is very similar to z-test. It just has longer tails, okay? So it is going to look something like this, which has longer tails. And we are looking for the 95% confidence level. So that means I will be sketching this area, and this area is 95%. And the remaining area on the left, I'll use a different marker. So the remaining area on the left is 2.5%, and the remaining area on the right is also 2.5%. The procedure is the same as the Z distribution, okay? Okay, so how do we deal with this number? Well, first of all, we need to calculate the degrees of freedom, okay? So degrees of freedom is equal to your sample size, which is 23, minus 1. That's equal to 22. All right. So we have 22 of degrees of freedom, and we will be using the t-table to pull the critical value out. Okay. Before we use the t-table, let me just clarify something here. So here, one tail value will be 2.5%, which is 0.025, and two tails will be what? It's the 5%, right? So the total is 5%, and that is 0.05. So why am I writing this? Because later this will be useful to pull the critical value out of the t-table. Okay? So you either look at the one tail or the two tails value. It doesn't matter which one you look at because they both will give you the same result. And then you pull the critical value out. Okay, so let's go ahead and take a look at the critical value here. The t-table is located on your Moodle account. So our degrees of freedom was 22, right? So you look at the first column here where it says DF, and you have to locate your degrees of freedom, and that is 22. It's given here. And then you look at the first and the second rows here. Again, it doesn't matter which one you look at. If you're looking at the one tail, then you should be looking at 0.05. I'm sorry, 0.025, 0.025. And if you're looking at two tails values, it's going to be 0.05 because both will give you the same result, right? Okay, so let's say that our one tail value is 0.025, which means your two tails, the accumulating value is 0.05. So you find the intersection between those 2 points, and that number is 2.074. Okay, once again, the first thing that you should be doing is looking at the DF column here, the first column on the left. You locate your degrees of freedom, you locate your DF, which is 22. Then you look at the first and the second column here, or again, it doesn't matter which one you look at. If you look at one tail here, and one tail is going to be 0.025, and those 2 points intersect here, which is 2.074. Okay. All right. So let me just go back. So the critical value t is equal to 2.074. Right? Actually, this is your t alpha over 2, right? Okay. Well, this is how you pull out the critical value from the t-table. All right, so up to this point, everything was regarding the t-test. So we understood how to pull critical values out of the t-table, and we understood the purpose of t-test. We know how t-test works in confidence interval related problems, right? So let's just go back to confidence interval. Now we understand the fundamentals of the t-test. We understand how t-test works. Let's just apply the t-test to find the confidence interval for any given average or any given mean. All right, so how do we calculate? Let me open a new page. So how do we calculate the margin of error for this? Margin of error is going to be equal to margin of, one second. I have to take the keyboard off. Okay, so margin of error was equal to, so that means E is equal to T alpha over 2, that's the critical value that you calculated or that you pulled from the table, times S, which is the sample standard deviation, divided by the square root of n. N is the sample size, right? Okay. All right. So the way that we calculate the confidence interval is the same. First of all, we take x bar, okay, x bar, and what is my x bar? If you can recall it from the previous lectures, what is my x bar? Okay, x bar, remember that x bar is the point estimate. We're using x bar to calculate mu. So we are relying on the sample's average to make predictions about the population average. So x bar is the point estimate, x bar minus E, that is less than equal to mu, and x bar plus E. Okay. So this is the formula for confidence interval for mean when the population standard deviation is not given. All right. In fact, this formula will be a part of this. Okay, so do not forget these two formulas here. Confidence interval for mean when the population standard deviation not given. Okay. Well, let's go over a problem to understand it. Example, let's say that we take a sample size of 10. We take a sample size 10, okay, and the average turns out to be 80 with a sample standard deviation of 4. Okay, now we want to build a 90% confidence interval for the average. Okay. All right. Again, the problem is we take a sample and the average turns out to be 80. It could be a sample of anything, right? And the sample size is equal to 10 and the average turns out to be 80 with a sample standard deviation of 4. And we want to build a 90% confidence interval for the average. Okay. Well, let's see what's given to us. So we know that n is equal to 10. Okay. And degrees of freedom is equal to 10 minus 1, which is 9. What else is given? And we know what S is. S is equal to 4. And X bar is equal to 80, which is given in the question. Okay. Well, and it's 90% confidence interval. So step 1. %90 confidence interval means the sketched area will be 90%. That means the remaining area on the left, let me use green this time. This will be 5%, and the area on the right will be 5%. So one tail is 5%, which is 0.05, and two tails will be the total of those two tails, and that is 10%, which is 0.1. Okay, so we need to calculate the critical value here. So what is T alpha over 2? All right, so let's look at the T table again. Degrees of freedom, it was 9. That's given here. Okay, degrees of freedom is equal to 9. All right, and one tail was 5%, and two tails was 10%. So 9, and we look at this. Not sure if I can highlight it. There you go. I'm trying to highlight these numbers, but it's not working for some reason. Anyway, there you go. So if you look at under this column here, you find the intersection point between your degrees of freedom and your confidence level, and that number is 1.83. Okay, so that is 1.83. All right, so the rest is pretty easy actually. Let's do it in black. So step number 2, you plug those numbers into the equation, and that is 80 minus 1.83 times 4 divided by the square root of 10. That is less than equal to mu. And 80 plus 1.83 times 4 divided by the square root of 10. Okay, and if you do the calculation, it will be 77.7. That's less than equal to mu, and the number is 8233. Okay, so that's the range, or that's the interval that we are looking for. So how do I interpret this result? That means I'm 90% confident, and that 90% comes from the question. I'm 90% confident that the population average will be between those two numbers, and those two numbers are 77.7 and 82.33. Okay? All right.